Hey everyone, we are moving on in our notes. We are finishing up the quadrilateral unit in the next day or two. So I know today was a little heavy on notes, but let's go ahead and get it over with so that we can move on. We are classifying quadrilaterals on the coordinate plane, right? So if we don't have a piece of graph paper or a coordinate plane available, we can do that using the distance formula and properties of quadrilaterals. So we know that rectangles and parallelograms have two sets of congruent side lengths, and rhombi and squares have all four sides that are congruent. So the first thing we check is the congruency of sides. So that's what I'm going to write. Check the congruency of sides. And then to determine whether or not it's a rectangle or a square, right, we know that the diagonals would be congruent. So step 2 is to check the congruency of the diagonals. Okay, so here we are, number 1. We are going to do the distance formula, and you guys know that distance formula is equal to the square root of the difference of our x's squared, x2 minus x1 squared, plus the difference of our y's squared, y2 minus y1 squared. And let's apply this to all four sides of my quadrilateral ABCD to figure out what it is. So we have side AB, side BC, side CD, and side DA.
I didn't understand that.
Okay. So here we go. We have the distance formula 4 times. So we are going to plug in to the formula my values x2 minus x1 squared plus y2 minus y1 squared. 8 minus 9 is negative 1. Negative 1 squared is 1. Negative 2 plus 4 is 2. Square it is 4. So we have the square root of 5 for side AB. Let's go ahead and find the length for BC. So same thing, I have the difference of my x values, 2 minus 8 squared, plus the difference of my y values, negative 5 minus negative 2 squared. 2 minus 8 is negative 6 squared, which is 36. Negative 5 plus 2, negative 3 squared is 9. So this looks like the square root of 45. Okay, so those don't match. Let's see what happens with CD. So CD, I have 3 minus 2 squared plus negative 7 minus negative 5. 1 squared is 1, and that looks like negative 2 squared, which is positive 4. So here we have our first matching side length. Okay, so I'm going to assume this is either a rectangle or a parallelogram. So let's go ahead and do the last one to see, because maybe it's neither. Maybe it's just some crazy shape. So I have DA. So that's going to be 3 minus 9 and negative 7 minus negative 4. So that's negative 6. 3 minus 9 36, and looks like positive 9, so square root of 45. So we have two sets of congruent side lengths, right? So this is either a rectangle or parallelogram, right? If it had been 4 congruent side lengths, then it would either be a rhombus or a square. So now, to determine whether it is a rectangle or a parallelogram, we check the diagonals. So we do the distance formula 2 more times, check my diagonals, that's going to be AC and BD. Okay, so I set up my distance formula for AC, right? So AC is going to be 2 minus 9 squared and negative 5 minus negative 4 squared, which leaves me with 49, right? 2 minus 9 is 7. Negative 7 squared is 49, plus negative 5 plus 4 is negative 1 squared, square root of 50. Okay, same thing here for BD. I know you guys are getting tired of the distance formula, so let's see. BD, I have 3 minus 8 squared plus negative 7 minus negative 2. 3 minus 8, that looks like 5 squared is 25. And negative 7 plus 2 is negative 5. Squared is 25. So I got the square root of 50. Alright, so are my diagonals the same? Yes, they are, right? These are the same. So I'm looking for my cases, right? And I was looking between case 1 and 2 for a parallelogram and a rectangle because they only have 2 sets of congruent side lengths. And when the diagonals are congruent, it is a rectangle. So ABCD is a rectangle. Okay, so you guys are going to do number 2 and 3. Okay, and I would like you to use the distance formula and not cheat and use a piece of graph paper because it's good for you. Right? The more you do it, the better it gets, easier it gets. Okay, so let's try to do these questions 1 through 8, quadrilaterals in the coordinate plane. The directions are use your knowledge of slope, distance, midpoint, and the properties of quadrilaterals to answer the questions. So number 1 says, on parallelogram PQRS, P is located at negative 1, 6, and S is located at negative 7, negative 3. What is the slope of QR? Okay, well, what do we know about parallelograms? Well, we know that the sides are congruent, and we also know that the sides are parallel. Okay, and so the fact that they're parallel is what we're going to use here to find the slope of QR, because if we find the slope of SP, then the slope of QR is going to be the same slope, right? Parallel lines have the same slope. Okay, so the slope of QR, and don't forget the slope formula, y2 minus y1 over x2 minus x1. Okay, that's straight from algebra. I'm going to do negative 3 minus 6 over negative 7 minus negative 1. Get negative 9 over negative 6, which is 3 halves, right? So positive 3 halves. Okay, so if QR, sorry, this was supposed to say SPS or SP. The slope of SP is 3/2. So because they're parallel, the slope of QR is also 3/2. Okay, so that's the answer to number 1. Let's try number 2. Okay, you guys do number 2. We're going to do number 3. On rhombus WXYZ, W is located at -5, -2. And Y is located at 3, -2. What is the slope of XZ? So another slope question. All right, rhombus. A rhombus has perpendicular diagonals, right? Just like a square. So let's see here. I'm going to find the slope of WY and then take the negative reciprocal of that to find the slope for XZ. So same thing, slope formula would be -2 minus -2 over 3 minus -5. 0 over 8 is 0. Okay, so what's the negative reciprocal of 0? Well, you can either think of this as a slope of 0, right, is a line going horizontally. So the negative reciprocal of that would be a line going vertically, which you guys know is undefined. Okay, or you can actually put 0 as a fraction, and the negative reciprocal of that would be -1 over 0, which you guys know is undefined. Okay, so the slope of XZ is undefined. Okay, number 5. Parallelogram STUV. S is located at -4, 1, and T is located at 5, 3. Find the length of VU. Length, we're finding the distance. So we know that parallelograms have opposite side lengths that are congruent. So I'm going to find the distance of ST and say that it's the same thing as VU. So let's use distance formula. I'll set it up. Here we go. So the difference of my x is 5 minus -4 squared plus the difference of my y's, 3 minus 1 squared. 9 squared is 81. 2 squared is 4, so this is the square root of 85. So if ST is the square root of 85, VU is also the square root of 85. Okay, so number 7, rectangle DEFG. D is located at -1, -1. And F is located at 4, -8. What is the length of GE? So we know that in rectangles, the diagonals are congruent, right? So DF is going to equal the same distance as GE. So same thing. We're going to use the distance formula. The difference of my x is 4 minus -1 squared plus -8 minus -1 squared. That is 5 squared is 25. -7 squared is 49. Okay, and so 25 plus 49 is 74. So this is the square root of 74 is DF, which is also GE. Okay, so you guys can either pause the video and do 2, 4, 6, and 8, or keep watching and do it at the end. And I'm going to move on here to beat the test. Okay. Number 1 says, in square ABCD, the diagonals intersect at G. Okay, so let's draw a picture. Oops. Here is my square. Okay, A, B, C, and D. And the diagonals bisect at point G. So here's G. Okay, so I drew the picture so that I could label my angles, right? Because the angles are here. It says angle AGD, that's this one here, is A plus 2B. And angle ABC is 2A minus B. Find the value of A and B. Okay, so what do we know? In a square, we have 4 right angles, and the diagonals are also bisecting and intersect at a right angle. Okay, so it looks like AGD, and so I'll write angle AGD is equal to angle ABC because they're both 90 degrees. All right, so what do we do with this? I have 2 variables here. Okay, I know that A plus 2B is AGD, and 2A minus B is ABC, and these equal 90. So when this happens, right, 2 variables, I think I'm going to solve for A in order to substitute it back in to find B, and then once we find B, we can sub it back in to find A. So let's set A plus 2B equal to 2A minus B. Okay, so let's go ahead and subtract A on both sides. And I'm left with 2B equals A minus B, right? Because 2A minus A is 1A. And if I am solving for A, I'll add B to both sides and get A equals 3B. Okay, so if A equals 3B, and I know that all the angles are congruent to 90, okay, then I can set sub in 3B for A into one of my equations and set it equal to 90. So I'm going to choose this one. I could have chosen the other one, but I think this one would be easier, right? And I can say A plus 2B equals 90, but instead of A, right, I found that A is equal to 3B. So instead of A, I'm going to write 3B plus 2B equals 90, which leaves me with 5B equals 90. And then when I divide by 5, I get B equals 18. All right, good. So we got B equals 18. That's the value of B. Let's plug it in here for A. Right, so I have 3 times B equals A. So that means that 3 times 18 equals A. And 3 times 18 is 54 equals A. Okay, so this is my second value. Let's see if this worked. So if I were to plug this in to my original equation, A plus 2B. So 54 plus 2 times 18 is the same thing as 54 plus 36, which does equal 90. All right, so good old substitution worked. So A is 54 and B is 18. All right. bringing you way back. Let's do number 2. Complete the proof. Given PQRS is a square. All right, so let's try to follow through the reasons in the statements to figure out these missing blanks. Okay, so if PQRS is a square, definition of square, all sides are congruent. Okay, so that gives me the idea that we're going to say that PQ is congruent to QR, which is congruent to SR, which is congruent to PS, right? All the sides are congruent. Okay, so if angle QP is congruent to angle Q, which is congruent to angle R, which is congruent to angle S, we can say that because P, Q, R, and S are all 90. So this is also a definition of square. Okay, specifically, all angles are congruent, right? We're not going to say that they're 90 just yet. Okay, so they go from 3 to 4, they drop their congruency symbol, so we know that that's definition of congruence. Okay, ooh, side angle side. Okay, so angle P is equal to angle Q, which is equal to angle R, which is equal to angle S. So we don't have a lot going on here, but we have these triangles that are congruent. Maybe I'll use my highlighter. I can see better. Oh. Okay. So side angle side. Let's see how they got that. We have PS is congruent to RQ, right? And we have SR is congruent to PQ. Okay. And then we have the right angles are congruent to the other right angles. So this looks like side angle side to me. Okay, so let's say that triangle PSR is congruent to triangle RQP. Okay, because of side angle side. And then once we have congruent triangles, okay, we can say PR is congruent to QS, right? Because of CPCTC, right? Congruent parts of congruent triangles, corresponding parts of congruent triangles are congruent. Okay, so now we're moving into trapezoids. We have non-isosceles trapezoids. Okay, they look kind of funny. They're trapezoids because they have 4 sides and 2 sides are parallel, right? But that's all they have. We have 2 parallel sides, and we can say that the consecutive angles between the parallel lines are supplementary. Okay, so what that means is that this plus this equals 180. Okay, and then I'll do 3 and 4. So this plus this is 180. Okay, so that's the consecutive angles between the parallel sides, right? And because these 2 angles are consecutive interior angles, if you can see it here with the parallel lines cut by the transversal. Okay, same for this one. We have parallel lines cut by a different transversal, so that makes these also supplementary. Corresponding interior. Okay, so isosceles triangles have more for us to use. Isosceles trapezoids have the same properties as non-isosceles trapezoids, plus the non-parallel sides. The legs are congruent, so this length is congruent to this length. The diagonals are congruent. Base angles are congruent. And opposite angles are supplementary. So this bottom left and top right are supplementary. Pretty cool. So here we go. Same thing with the consecutive angles between parallel sides, right? That would be the same thing as saying that these two are supplementary because they are consecutive interior angles. Okay, so number 1, find each missing value on the trapezoid. Okay, so same thing. Parallel lines cut by a transversal. How are we going to find angle K? Right, so we know that this one's 51 and K is consecutive interior. So we're going to do 180 minus 51 to get angle K is 129. Okay, same thing with this angle here. We have a different transversal. And so 87 plus whatever this angle is equals 180. So that would be 93. Okay, let's do number 3. My parallel lines cut by a transversal. Hopefully this helps you see. Okay, these are consecutive interior. So I'm going to say 8x plus 6 plus 54 equals 180. Okay, I'll combine like terms. Subtract 60 on both sides and get x equals 15. Okay. Number 5, DEFG is an isosceles trapezoid. Okay, so we know that DG was an isosceles trapezoid. So my non-parallel legs are congruent. So DG is congruent to EF. And DF, my diagonal, is congruent to EG. Okay, number 7, the measure of angle Q is, well, don't think too hard, guys. If this is 112, okay, this S is going to be 180 minus 112, which is 68. Okay, and so that makes angle R 68, and that makes angle Q 112, right? Because these have to be the same if they are supplementary. Number 12. WXYZ is an isosceles trapezoid. Find each missing angle. Okay, so we know that W and Y are supplementary. So I'm going to say that 10x plus 5 plus 6x minus 1 equal 180. 16x plus 4 equals 180. 16x equals 176. X equals, okay, I need to get my calculator. 11. Okay, so let's find W, X, Y, and Z. So plugging in 11, that's 10 times 11. 10 times 11 plus 5. So 110 plus 5 is 115. That makes angle X 115. Okay, angle Y is 66 minus 1, which is 65. Okay, and then these two are also supplementary, so that worked out well. So angle Z is 65. Okay, I'm going to leave you 13 and 14, and we're going to beat the test. So here we go. I have MATH, very creative, is an isosceles trapezoid. Prove angle MHA is congruent to ATM. Okay, so these angles are congruent. That's what we're trying to prove. Okay, so let's use the question bank. This is going to be like a proof on your EOC, right? They give you a bank and you have to drag and drop. Okay, so number 1. It is given that MATH is an isosceles trapezoid. We can prove that MH is congruent to AT because of the... All right, well, let's try to figure this out. We have trapezoid diagonals theorem. Well, are MH and AT diagonals? No. Okay, are they base angles? No. Are we using the midsegment? No, I don't think we're using it at all, but we'll leave it there. Definition of isosceles trapezoid. Yes. Okay, so this is definition of isosceles trapezoid, because that's what we've got so far. So then state that MA is congruent to MA by the reflexive property. We can state that AH and MT are congruent. So AH, so this is a diagonal, and MT are congruent by the, we just said those are diagonals, so hopefully that's giving you a hint, by using the trapezoid diagonals theorem. Okay, now we have triangles AHMA and congruent to triangles TAM. All right, let's highlight HMA. Okay, TAM. Sorry. Are congruent by they gave us this is congruent to itself. Okay, we know that the diagonals are congruent, so it looks like we have side, 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 right? We have 3 sides of one triangle are congruent to 3 sides of another triangle. Okay, and finally, by using, well, anytime you have a triangle proof and you're trying to prove parts, okay, corresponding parts of congruent triangles are congruent. So finally, by using CPCTC, we can prove that the angles are congruent. Okay, so you are going to fill in all of the ones that I skipped, and this should keep you busy and get you ready for Friday. I hope you guys have a good day off. Okay. Good night. Bye.